Hi everyone, I am Harihanji from Mechanical Second Year GCT. Clutch is a mechanical device used for transmit the rotary motion of one shaft to another when desired. The axis of the shaft are coincident. In simplest application, clutch connect and disconnect two rotating shaft. In this device, one shaft is typically attached to an engine or other power unit, while other shaft provides output for work. A clutch is simply a device. It transmits the rotary motion, which rotary motion is present in one shaft, and it transmits the motion to another shaft while connecting it to it. Um, Frictional clutches is nothing. It's same like clutches which transmit rotary motion by friction. Types of frictional clutches are disc clutch, single plate clutch, multi plate clutch, cone clutch, and centrifugal clutch. Single plate clutch. Disc clutch consists of a clutch plate attached to a splined hub which is free to slide axially on spline cut on the driven clutch. The plate is made of steel and has a ring of friction lining on its side. The engine shaft supports a rigidly fixed flywheel. A spring-loaded pressure plate presses the clutch plate firmly against the flywheel when the clutch is engaged. When disengaged, a spring presses against the cover attached to the flywheel. Thus, both the flywheel and pressure plate rotate with the input shaft. The movement of the clutch pedal is transferred to the pressure plate to thrust bearing. And the axial pressure exerted by a spring provides a frictional force in the circumferential direction when the relative motion between the driving and driven members tend to take place. Um, if the torque due to this frictional force exceed the torque to be transmitted, then no slipping force takes place, and the power transmitted from the driving shaft to the driven shaft, where we have thickness. Now we consider two frictional surface maintained in contact by the axial thrust. Simply, the simple clutch is saying that if we press the clutch plate, um, the pressure plate will move against the clutch plate. Hence the clutch plate will get disengaged when we press the when we release the clutch plate. um, the pressure plate will press the clutch plate, and which in turn engage the frictional plate. This is the main concept of single plate clutch. um, Now consider two frictional surfaces maintained in contact by the axial thrust W. Let T be the torque transmitted by the clutch. P is equal to intensity of axial pressure R1 and R2 are external internal area of frictional phase. Mu is the coefficient of friction. As you know, the area of contact of surface or frictional surface is 2 pi r into dr. Normal force on the wing is dou W is equal to pressure into area, which is P into 2 pi r dr. By substituting, and frictional force Fr is equal to mu into normal force, which is mu P into 2 pi r dr. Therefore, frictional torque acting on the wing is T is equal to Fr into r. By substituting Fr value, and finally we get 2 pi into mu into P r square dr. This is the single plate clutch. These two this is the single plate disc, and these two are the frictional surface. And multi-plate clutch. Multi-plate disc clutch may be used when a large torque is to be transmitted. The inside disc, usually of steel, are fastened to the driven shaft to permit the axial motion. The outside disc, usually made of bronze, are held by bolts and are fastened to the housing which keyed to the driving shaft. The multiple disc clutch are extensively used in motor car, machine tool, and etc. Um, Multi-plate clutch consists of many frictional plate. This is same like single plate clutch. Pressing the clutch plate, pressure plate will move against the frictional plate. Disengage will press off the clutch plate. Pressure plate will move towards the frictional plate. Therefore, the frictional plate will become axial force become less, and it is become engaged. That N1 is the number of disc on driving shaft, N2 is the number of disc on driven shaft, N is equal to N1 plus N2. minus 1, and total frictional torque acting on the frictional surface is T is equal to N into mu into W into R, where R is the mean radius, which is equal to 2 by 3 into R1 cube minus R2 cube divided by R1 square minus R2 square. Therefore, total frictional torque is equal to R1 plus R2 divided by 2. In cone clutch. In cone clutch, the contact surface are in the form of cone. In the engaged position, the frictional surface of the two cone A and B are in complete contact due to the spring pressure that keeps one cone pressed against the other all the time. When the clutch is engaged, the torque is transmitted from the driving shaft to the driven shaft through the flywheel and the frictional cone. For disengaging the clutch, the cone B is pulled back to the level system against the force on the spring. The main advantage of the cone clutch is the normal force on the contact surface is increased. If here the cone clutches, the contact surface are like in the shape of a cone. You see here the contact surface is in the shape of cone, and if you consider F is as axial force, the normal force, and the semicone angle of the clutch for conical clutches, we can derive the equation like frictional force and normal force F1 is equal to F by sin alpha. F is equal to 2 pi PR into R0 minus Ri, which we have derived before in single plate clutch, which is equal to 2 pi PRB, since sin alpha is equal to R0 minus Ri by B, so that term get cancelled. We get 2 pi P into R into B, where P is the pressure, B is the width of the cone face, and T is equal to torque is equal to mu F divided by 2 sin alpha R0 plus Ri, which is torque is equal to mu into Fn into Rm. Rm is the mean radius. Centrifugal clutch. Centrifugal clutch are being increasingly used in automobiles and machines. A centrifugal clutch as a driving members consists of 4 sliding block. As the speed of the shaft increases, the centrifugal force on the shoe also increases. When the centrifugal force exceeds the resisting force of the spring, the shoe moves forward and presses against the inside of the rim, and the torque is transmitted to the rim. In this way, the clutch is engaged only when the motor gains sufficient speed to take up the load in an effective manner. The outer surface of the shoe are lined with some frictional material. Now the derivation part. M is the mass of each shoe. It has 2 shoes. The centrifugal clutch has, you can see it has 2 shoes, and R is the inner radius of the pulley. Small r is the distance of the center of mass of each shoe from the shaft axis. N is the number of shoe, and omega is the normal speed of the shaft. Omega dash is the speed at which the shoe moves forward, and mu is the coefficient of friction between the shoe and the rim. Now the derivation is centrifugal force acting on the shoe is Pc equal to m into omega square r, and inward force of the shoe exerted by the spring at the speed at which the engagement begin to take place. Therefore, Ps is equal to m into omega 1 square into r. The net outward radial force is Pc minus Ps, the difference of these two forces. The frictional force F is equal to mu into Pc minus Ps. Therefore, the frictional torque, which is equal to frictional force into R, which is mu into Pc minus Ps into R. Total frictional torque transmitted, total frictional torque T is equal to mu into Pc minus Ps into R into N. Substituting the frictional torque value with N, we get N into F into R. From this expression, the mass of shoe may be evaluated. Thank you.